Here. Today we're going to be doing Unit 2, Notes 2. So we're going to talk about graphing systems of inequalities. Okay, so yesterday you did graphing systems of equations, so you're figuring out where the 2 points cross. Today we're going to be doing inequalities, which means we're actually going to be looking for shaded regions that overlap. So a system of linear inequalities is a set of 2 or more inequalities graphed on the same graph. Makes sense, right? System means that there's 2 of them, and what we're actually looking for the solution is that it's the region where both of the inequalities are shaded. So you'll notice where that solution overlaps, and that's going to be your answer. Okay, so let's go ahead and let's take a look at graphing these. So first, let's kind of remember how we graph them. Remember that if it's facing towards the y, you shade up. If it's facing away from the y, you shade down. If there's no line underneath, you use a dashed line. If there's a solid line underneath, you use a solid line. So let's graph this first one. We're crossing the y-axis at 1. And then our slope is -1, which is the same as 1 over 1. So we're going down 1, right 1, down 1, right 1. So now I'm going to actually connect that with a dashed line. So I noticed for that first one that the alligator is facing away from the y, which means I need to shade down. So I'm just going to lightly use vertical lines. Now I find on this that it helps students a lot to have 2 colors. So if that's something that'll help you visually see, go ahead and do that. So then you're crossing the y-axis at 3, which is right here. Then your slope is 2, which is the same as 2 over 1. So it means you're going from that 3 up 2 and over 1. Now for this one, you want to connect using a solid line because there's a solid line underneath the inequality. Now for this one, again, you're shading down. So now I want to focus on the region where both my colors crossed, and that's this region down here. Now notice when I shaded in, I shaded underneath each line entirely. That's going to help me see where they overlap. And I like to shade that in really dark so it's really obvious to me when I'm grading it that you know that that's the solution. So let's go ahead and let's take a look at this next one. So we're crossing the y-axis at 1, and then our slope is up 1 over 1, up 1 over 1. So for that one, I'm going to use a dashed line because there is no line underneath it. Now, the alligator's facing the y, which means I need to shade up. So I'm just going to lightly shade up. Now, taking a look at the next one, we're crossing the y-axis at a -3. So I'm crossing the y-axis at a -3, and again, my slope is 1. So up 1 over 1, up 1 over 1. Plotting each of those points. So then through there, I'm going to draw a dashed line, and this time it's facing away from the y, so I'm going to shade down. Now I notice that on the entire graph, my solution, or my 2 shaded regions, never cross. So if they never cross, there's no overlapping region, that means that you have no solution. Similarly to when you had parallel lines in the past. Now just because they're parallel doesn't necessarily mean you have no solution. Okay, it could mean that there is still a shaded region, meaning in the middle where it's both shaded. So keep that in mind. Now let's take a look at number 3. So in order for us to graph these, we're going to have to solve them for the y. So let's go ahead and let's do that. Okay, so I'm going to solve this top one for y. So I have 3x minus y is greater than or equal to 6. So the first thing I'm going to do is subtract 3x from both sides. And then I get -y is greater than or equal to -3x plus 6. Now there's basically a -1 in front of this y, and we don't want to divide things by negative numbers, or leave a negative number there. So what I'm going to do is I'm going to divide both sides by a -1. Now when I'm doing that, I should have alarm bells going off in my head, thinking way back to Unit 1, Notes 2. Remember that when you divide an inequality by a negative, you need to flip the symbol. So I need to flip my inequality symbol that I'm graphing. 3x divided by -3 is 3x, and 6 divided by -1 is -6. So when I go to graph, I'm actually going to use this final version right here. That's the one I'm going to graph. So I'm crossing the y-axis at a -6. Now that's going to be right here. And then my slope is going to be 3 over 1. So going up 1, 2, 3, and over 1. Okay, so there's a solid line underneath my inequality, so I am going to draw a solid line. Now when I look at my final region, I notice that the alligator is facing away from the y, so I do need to shade down from this line right here. Now we need to go ahead and solve for that second inequality. So we have 2x plus y is less than or equal to 4. So all we have to do is get that 2x over to the other side. Since it's positive, you need to subtract 2x. So we get y is less than or equal to negative 2x plus 4. So if you go up here, we're crossing the y-axis at 4, and then my slope is negative 2, so I'm going down 2, right 1, down 2, right 1. And I'm again going to use a solid line because there's a solid line underneath. In my final version of the equation, the alligator's facing away from the y, so again, I'm going to shade down underneath the entirety of the line. So then I notice that they crisscross right here, so I'm going to shade that in a lot darker for number 3. Now let's take a look at number 4. First, this x is less than or equal to 3. If you ever have an x in an equation and there is no y, that means you're going to have a vertical line. So to graph that vertical line, you're going to find x on the y-axis, or on 3 on the x-axis, and through that you're going to draw a vertical line. Now it's going to be a solid line because there's a solid line underneath the inequality. So now we want x to be less than 3. So we want it to be smaller than 3. So look at the x-axis as a number line. Which way is it smaller? It's getting smaller on the left side. So I'm going to shade on the left side. Now, for the second one, we need to solve that for y. So we have x plus y is greater than 2. So I'm going to go ahead and subtract x from both sides, and I get that y is greater than negative x plus 2. So we're crossing the y-axis at 2. That's going to be right here. Then my slope is negative 1, so that means I'm going down 1, right 1, down 1, right 1. And through that, I need to draw a dotted line because there's no line underneath the inequality. And at the end result, the y was facing towards the y. The alligator is facing towards the y. So I'm going to shade up. Now, when I do that, I end up in this region right here. So this region right here is your final answer for number 4. Now let's take a look at number 5. So for number 5, if you ever have strictly y in it, that means you're going to have a horizontal line. So I'm going to find 3 on the y-axis, and that's going to be right here. And I'm going to have a dashed horizontal line through it because there's no line underneath my inequality. Where is y getting bigger, as you go up or as you go down? Well, it's getting bigger as you go up, so I'm going to lightly shade up there. Then, for my next one, I'm crossing the y-axis at 4. So I'm going to go ahead and plot 4 on the graph. And then I'm going down 1, right 1, down 1, right 1. And that's also going to be a dashed line. Then I know I'm shading up from that line. So then the region that the two colors overlap is right here. So I'm going to make that really dark so we know that that's my solution. Taking a look at number 6, we're crossing the y-axis at a positive 2. And then my slope is 2, which is the same as 2 over 1. So I'm going up 2 over 1, up 2 over 1. Now through that, I'm going to have a dashed line. Okay, and I'm going to shade underneath that dashed line because the alligator is facing away from the y. Now let's go ahead and let's take a look at this next one. So we're crossing the y-axis at negative 3. So I'm going to find negative 3 on the y-axis, and then my slope is negative 1, which is the same as negative 1 over 1. So I'm going to go down 1, right 1, down 1, right 1. And through that, I'm going to have a solid line because there's a solid line through that inequality. And it's facing towards the y, so I'm going to shade up. So this right here is the region that it overlaps, so I'm going to shade that one in a lot darker. Okay? So let's take a look at some of these word problems here. The most Jack can spend on bagels and muffins for the cross-country team is $28. A package of six bagels costs $2.50. A package of muffins costs $3.50 and contains 8 muffins. So we want to write an equation or write a system to figure out what we need. Well, first of all, let's talk about pricing. Okay, so I'm just going to scroll down so I have a little bit more space here. So let's just talk about pricing. For every X bagel that I buy, it's going to cost me $2.50, which you can really write as 2.5. For every Y muffin, it's going to cost me $3.50, which you can write as 3.5. And that needs to be less than or equal to 28. So that's for the pricing. So when we're doing systems of equations, we're going to need more than one equation. So let's just work with this one for a little bit. I'm going to solve for x. So I'm going to subtract 2.5x to the other side. Now I can't subtract the 28 and the 2.5x because one has an x and one does not. So then I get negative 2.5x plus 28. Oops, not 2.8, 28. And then I'm going to go ahead and divide both sides by 3.5. Now this ends up being an icky number, so we'll deal with that in a second. I'm just going to write it as negative 0.714 x, and then 28 divided by 3.15 is going to give me 8. So that's one equation. Now, we need to talk about the number of bagels that we need to buy, okay? So for every X package of bagels that I buy, I'm going to end up getting 6 muffins. And it says that I need to have at least 12 bagels. So if I have more than 12 bagels, that would be good. So now I'm going to go ahead and I'm going to solve that for x. So I'm going to divide both sides by 6, and I get that x is greater than or equal to 2. Okay? Then I need to do the same thing for y. Okay? So for y now, for every y thing of muffins I buy, I need to have it has 8 muffins. However, I need to have at least, so if I have more, that would be good, 24 muffins. Divide both sides by 8, and you end up getting that y is greater than or equal to 3. So now we're going to graph each of those. Let's start by graphing y is greater than or equal to 3. So I'm going to find y on the x-axis, and I'm going to go up 3. Through here, I'm going to draw a solid horizontal line. Now, I want to have at least 3, so I'm just going to shade lightly above it. And I'm not going to go all the way up because we're not going to be up that high once we graph everything. Then, let's go ahead and let's graph our muffins. Or our bagels, I'm sorry. So we have x is greater than or equal to 2. So I'm going to find 2 on the x-axis, which is right here. And I'm going to have a solid vertical line going through there. Now I want it to be bigger than that line. And for the x-axis to get bigger, you have to go to the right. So now I have a giant shaded overlapping region that's going to be cut down by our final one. So we're crossing the y-axis at 8 for that first equation that we wrote. Okay, we're crossing the y-axis at 8. So we're going up 1, 2, 3, 4, 5, 6, 7, 8. And we're plotting that point. And then the slope is negative 7.14. So what I'm going to do is I'm going to go almost all the way down and over 1 to represent 0.7. Almost all the way down and over 1. Now I'm going to go ahead and graph that. So our overlapping region is this region. This little triangle right here represents our number of solutions. Now it says to give an example of 3 different purchases he could make. I'll give you one and then I want you to find 2 more. All you're going to do is find a point within this graph. So I could go over 3 and up 1, 2, 3, 4. So the point 3, 4 is on the graph, which means he could get 3 things of bagels and 4 things of muffins and fit all of those constraints. Go ahead and find 2 more for me. Let's take a look at this one. Rondell makes $10 an hour cutting grass and $12 an hour raking leaves. So let's let X represent cutting grass and Y represent raking leaves. And he cannot work more than 15 hours per week. So we're going to use a graph to represent this. So for every X hour he cuts grass, he's going to make $10. For every Y hour he rakes leaves, he's going to make $12. He wants to earn at least $120. So this equation deals entirely with money. And I want the inequality facing that way because he would like to make more than $120 if he could. So the first thing I'm going to do is subtract 10x over to the other side. Again, I can't combine the 10x and the 120 because one has an x and the other doesn't. Then I'm going to divide both sides by 12, and I end up getting y is equal to negative 10x divided by 12 can be reduced to a pretty easy fraction, which is negative 56x plus 10. So that's one of them that we want to. So that's one of our restrictions. Let's go ahead and graph that one. So going up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going down 1, 2, 3, 4, 5, and over 6. 1, 2, 3, 4, 5, and 6. One more. So we're going to have a solid line. And we are going to shade up from that line. So I'm just going to draw it lightly because I know I'm going to have an upper bound here in a second. So let's go ahead and let's take a look at this next one. He's also restricted by the hours. Between the hours he rakes leaves and the hours he cuts the lawn, it cannot be more than 15 hours. So when we subtract the y over to the other side, we get that y is less than or equal to negative x plus 15. So now I want to find 15 on the y-axis. So here's 10, and then 11, 12, 13, 14. So here's 15 right here. And then I'm going down one, right one, down one, right one. And I'm going to use a solid line. And then from there, I'm going to shade down. So really in between these two lines represents a number of different ways that he can work. So let's take a look at this one here. So we first get that x is greater than or equal to 0. So x is equal to 0 is really just the y-axis. So that's going to be a vertical line right through the y-axis, like so. And we want x to be greater than 0. So in order for it to be greater than 0, we're going to have to go to the right because that's where x is getting bigger. Now, we need to solve this next equation in order to use it. So we have x minus 2y is less than or equal to 2. So the first thing I'm going to do is I am going to subtract x from both sides. And then once I do that, I end up getting negative 2y is less than or equal to negative x plus 2. Again, those can't be combined. Now I'm going to divide both sides by a negative 2. Now, when I do that, I need to flip the symbol. Negative x divided by negative 2 is going to become 1/2, and then x, and negative 2, or 2 divided by negative 2 is negative 1. So we're crossing the y-axis at negative 1, which is right here. And then I'm going up to 1 and over 2, which is right here. So I'm going to have a solid line through those 2 points, and then I look at my ending inequality. So I am going to shade down. So far that area right there is my overlapping region. Now I need to solve this final one here. So then I end up getting 3x plus 4y is less than or equal to 12. Well, first thing I want to do is subtract the 3x from both sides, and then I get 4y is less than or equal to a negative 3x plus 12. Okay, so then you end up getting y is less than or equal to negative 3/4 x plus 3. So you're crossing the y-axis at 3, and then you're going down 3 and right 4. You're going to use a solid line there. Oops, wrong, Miss Humbert. I'm sorry, you're crossing the y-axis at 3. Yes, I'm right. I'm sorry. I need to trust myself. So then your overlapping region is right there. Because this one should have been shading up. That was my fault. Because I forgot to change the sign. Good one, Miss Humbert. So then let's go ahead and let's take a look at this last one here. So we have y is greater than 2. So we're going to cross the x-axis at a vertical line with 2. And we want it to be less than, so we're going to go ahead and shade this way. Then we're crossing the y-axis for the next one at 0. Okay? Happy lunch to you all. So then we're going up 1 and over 4. So I'm going to have a dashed line through there. And then from that point, I'm going to shade up. So over here in the corner is my current location. So now for the next one, we're crossing the y-axis at 9. So that's just going to be slightly above the axis there. And then from there, we're going to go up 2 and over 1, which we can't. So instead, I'm going to go down 2 and left 1. Again, I'm going to use a dashed line because there's no solid line underneath. And then it's eating the y, so I'm going to shade up. So this upper left-hand corner right now is our bounds. Finally, we need to solve this last one for y. So we have x plus 3y is less than 9. So I'm going to subtract x from both sides, and I get 3y is less than negative x plus 9. Divide both sides by 3, and then I get y is less than negative 1/3 x plus 3. So we're crossing the y-axis at 3. And then our slope is negative 1/3, so I'm going down 1, right 3. Again, using a dashed line. Now, it's facing away from the y, so I need to shade down. So my overlapping region of all of these ends up being in this corner right here. So that concludes your note video for today. You can go ahead and start the practice once you are done. Thanks for listening.